Hi guys, it's Dr. Justin Southey here, going through some questions on directional derivatives. And we asked in this one to find the maximum rate of change of f at the given point. So f is this function here, tan of blah blah blah, and at the given point minus 5, 1, 1. We asked to find the maximum rate of change and the direction in which it occurs. And of course we've got that lovely theorem which tells us that this is very much linked to the gradient vector. So we're going to go ahead and work out the gradient vector. Del of f at a random point x, y, z, and we know that that's simply the vector where the first entry is the function differentiated with respect to x, second entry is the function differentiated with respect to y, and the third entry is the function differentiated with respect to z. So we want to differentiate this guy with respect to x. Well, it's the tan of a function of x, so we have to differentiate the outer function first. That gives us 6 squared of x plus 2y plus 3z multiplied by the derivative of the inner function with respect to x. So x just becomes a 1. We multiply by 1 plus, well, this is a constant with respect to x, constant with respect to x, they both disappear. So now we need to differentiate with respect to y. So again, the outer function, we differentiate that and we get 6 squared x plus 2y plus 3z. And now when we differentiate the inner function, that's a constant. 2y differentiates to 2, and 3z is a constant, differentiates to 0. Finally, we need to differentiate with respect to z. Once again, we get 6 squared x plus 2y plus 3z multiplied by the derivative of the inner function, in this case, is 3. And that's the gradient vector, or nabla of f, at any point x, y, z. We're interested in the gradient vector at the point minus 5, 1, 1. So we go ahead and simply substitute into that. Now all three of these points have got this factor 6 squared of x plus 2y plus 3z. So let's evaluate that first. X is minus 5, y and z are 1. So we've got minus 5 plus 2 times 1 plus 3 times 1. Minus 5 plus 2 plus 3. Well, of course, that gives us 0. And what's the sec of 0? Well, the sec of 0 is 1 over the cos of 0. Cos of 0 is 1. So sec of 0 is 1 over 1 is 1, and we square that, we square 1, and we just get 1. So this, all of this here, evaluated at this point, is simply 1. And that's true for this over here, and this over here as well. So this is equal to, that thing is 1 times 1. The second entry, we've got 1 times 2. And the third entry, we've got 1 times 3. So the gradient vector at the point minus 5, 1, 1 is simply equal to 1, 2, 3. Now, what did the question want? Well, it wanted the maximum rate of change at f at the given point and the direction in which it occurs. Well, we've got this theorem that says the direction of maximum rate of change at any point is simply the directional vector at that point. So the direction of maximum rate of change is going to be the direction 1, 2, 3. It's equal to the gradient vector. And the theorem goes on to say that the actual rate of change, that max rate of change, is equal to the magnitude of the gradient vector. So we're looking for the magnitude of the vector 1, 2, 3, and that's simply equal to the square root of 1 squared plus 2 squared plus 3 squared. So that's 1 plus 4 plus 9. 1 plus 9 is 10, plus 4 is 14. So it's the square root of 14. Direction of maximum rate of change, gradient vector. The maximum rate of change is the magnitude of that vector. Nice and easy.